Reciprocal of a linear function. So a linear function, of course, is like your y equals mx plus b. It's a straight line, right? So like 1 over x would be the reciprocal of a linear function because the y equals x is a linear function. What does a reciprocal of a linear function look like? Well, you should have seen this in grade 11, actually. You hopefully should know that it looks something like this. Oh, sorry, let's try that again. Looks something like that. So what's happening here is that this linear function seems to be two separate lines. There's a piece on top here, and there's a piece down here. This should look familiar to you because, like I said, this is something that you should have done back in grade 11. Make this a little bit bigger for you, right? And this thing has something we call asymptotes. It has a vertical asymptote. It has a horizontal asymptote. What's an asymptote? Well, does anybody remember what an asymptote is? Does that word sound familiar to you? Who is that? Whose hand is that? No, that's Jeremiah. Jeremiah, go ahead, please. Okay, that's actually a pretty good explanation. Just so you know, there are some horizontal asymptotes that the graph can actually not only touch but cross over. And we'll get to those later on. But vertical asymptotes absolutely are never breached. So there is a vertical asymptote. I put the vertical asymptote in for this line. Vertical asymptote would be a line like this line here at the y-axis, which I'm putting in right now, which the function is moving towards on the right and moving towards on the left, if you follow the path that I'm tracing with the mouse, but it's not actually touching the line. That's a horizontal, that's a vertical asymptote. And I put the equation of vertical asymptote in a minute. Let me also put in the horizontal asymptote. So there's a horizontal asymptote that goes horizontally along the x-axis, which does the same thing. The function is moving towards it on this side, moving towards it on that side, doesn't actually touch it. So let's put in what those asymptotes are. Each asymptote is a line, and every line has an equation. So I'm going to put in the equation of the line for the vertical asymptote and the equation of the line for the horizontal asymptote. We'll start with the vertical asymptote. Vertical asymptote equation, remember, is this line right here, which is going straight up and down, which you normally call the y-axis, but we're going to call it the x equals 0 line. Something that you'd have learned also in grade 9. That the y-axis equation, the line has an equation, and it's the x equals 0 line. Why is it called that? Because every single point along this line, right, you see me tracing it out, every single coordinate on this line has an x value of 0. So for instance, this point here is 6, 0. This point down here is minus 4, 0. Sorry, I'm not saying that right at all. This point here is 0, 6. This point down here is 0, minus 5, and so on and so forth. Every single x coordinate along this line is 0. Okay? So we call the x equals 0 line. The horizontal asymptote is this line right here. And you can probably guess what the equation of that line is, because if this was the x equals 0 line, then this is the y equals 0 line. Okay, and in both cases, the function is trending towards it here, trending towards it there, moving towards that horizontal asymptote, moving towards the vertical asymptote on either side. Okay, next question. So we know the asymptotes are at x equals 0 and y equals 0, both equations of lines. What are the intercepts, x and y? Let's get to the x-intercepts first. Where does this function, right, this purple line that was drawn by the smartboard, where is the x-intercept on this function? Okay, Jeremiah, I see your hand up. Go ahead, please. There are none. There are none. There's a reason why there are none, by the way. Let me remind you about how you find x-intercepts. You find x-intercepts by setting your y to 0. Think of this as being y equals 1 over x. Right? Instead of saying f of x, we can say y equals 1 over x. So if I'm trying to get my x-intercepts, I'm going to set 0 is equal to 1 over x. Well, the only way to solve this is by cross-multiplying. And by cross-multiplying, I mean take the bottom of this side times top of that side. It will be x times 0, which is just simply 0, is equal to 1. And of course, that's not true. So it means that there really are no solutions. Harish is now checking in. I'll just mark you here, but I'm going to have to mark you late, Harish. But thanks for letting me know that you are, in fact, here. Okay, back to business here. So there are no x-intercepts because there's no way to get 0 if I have 1 over x. There's no way to get a 0 there at all, because if I cross multiply, I'm going to get 0 equals 1, which I can't solve that. So there are no x-intercepts. Okay. And as you can see, the line is never actually touching the x-axis, right? It never actually touches it anywhere. It's moving towards it on both sides, never actually touches it. So none. How about y-intercepts? Okay, can anybody tell me what the y-intercepts of this function are? Where are the y-intercepts of this function? Come on, folks. There's a class of like 20, a lot of you. One of you is supposed to know. Okay, Jeremiah, see your hand up. Okay, okay, go ahead, Jeremiah. What do you think? Where do you think the y-intercepts are? Thanks, Karis. Thanks, Axa, and thanks, Jeremiah. There are none. Is that always the case? No, we'll see in a little while when that's not the case. So we sketched the function. That was number 3. Function is already there, all right? Drawn by the smartboard. That's why I'm using the smartboard today. End behavior. No, think back to when we were doing end behavior at the beginning of this course. We talked about Q this and Q that, from Q3 to Q1, from Q2. That's how we described end behavior back then. But that's not going to work now. So we can't use the quadrants to describe end behavior. So we're going to have to use it the other way that we described end behavior, which is as x approaches minus infinity, what's the y doing? And we're going to do it the other way. When x approaches positive infinity, what's the y doing? That's how we describe end behavior sometimes. We did back then as well, right? Not only now, but we did back then. When we were looking at end behavior, we also use this kind, apart from saying Q this to Q that, we also use this way of looking at it. Okay, so let's ask the question again now. As x approaches minus infinity, so that means I'm going further and further to the left, right? You can follow where the mouse is pointing. I'm going further and further to the left. And as Jeremiah, I see your hand up, so just hold the thought for a minute. As I go further and further to the left, what y value does it seem that the graph is approaching? Okay, Jeremiah, go ahead, please. You have an answer? Well, let's hear what Janaya thinks. So now you have your hand up as well. What were you going to say? Okay, that's an interesting answer. So we have 2 different answers. Janaya and Jeremiah are not on the same bus on this one. Well, let's see if we can figure it out, right? Follow as I move the mouse to the left, right? And think about the y values. Now, y values are, where am I on the y-axis? So as I move further and further this way, it looks like if I started off at 0, the y value is way down here. But as I get closer and closer and closer to minus infinity, I'm never going to get to minus infinity, by the way, because I can't. It's minus infinity on the number line. What's happening to my y values? Are they getting bigger, smaller? What's happening to them? They're actually getting smaller. So I'm going to have to agree with Jeremiah on that one, that I'm approaching 0, right? My y values are shrinking as I get further and further away. As I move along the x-axis this way, my y values are getting, you see, as you move this way, the y values are dropping, getting smaller and smaller. I'm moving this way along the y-axis. In fact, I'm going closer and closer to 0. Okay, does that make sense to everybody? I don't just mean Janaya, but everybody else. Does the rest of the class, does that? Okay, great. How about if I'm going the other way? As I approach infinity, right? So that was negative infinity. What do you expect to be happening as I approach infinity? So I'm going to go from this side now, end behavior going this way. So I went this way before. What happens as I go towards positive infinity? What value of what value of y, I should say, am I approaching as I move this way? Can anybody help me with that? The y's are still getting small. So you're going to 0 as well. They're going to 0 as well. Good stuff. All right, some other questions that we have to answer. Thank you very much, by the way, Emily and Keontae and Noah. Let's talk about domain and range. Again, something that you would have learned back in grade 11. Let's talk domain first. Domain, remember, is all of my possible x values. How far does my x extend? Let's go back and let's look at the graph again, right? As I go to the left, as I go to the right, okay, Omar, seems to be something that happens at the beginning of every class. You got to make sure that you try and be ready for class when you come to class. You don't have to be doing this every single day. But I'll see you in about 5 minutes, Omar. Okay, go. All right, back to what we're saying. Can anybody think of a way that we can state what the domain of this function is, right? Think about, as I go to the left, as I go to the right, does the function stop anywhere, or is it everywhere that I have? So can you think of a way that I can phrase that? What's the domain of this function? Anybody? What domain is? Domain is my possible x values. Does anybody have a solution for that? Or should I just jump in and give it to you? Okay, I'll tell you what it is. The domain of the function, okay, Jeremiah. Mhm. Mhm. Good, good, good. So here's another way we can say that the domain of the function is all real numbers as long as x is not equal to 0. So we're saying it's anything except 0. All right, pick any number you like except 0. There's a one exception to, so one way to write what the domain is to write what we just wrote. XCR, but x is not equal to 0. Not that answer is not different from what Jeremiah said. It's just that I think this is another way that we can express it. Well, I think you can figure out from there what the range is. Range is my possible y values, and it's very similar, except I'm going to say that it's all real numbers, but y is not equal to 0. And that's because of the fact that as you go up and as you go down, there is one place that you don't have anything on your graph. In fact, your graph is splits apart at 0. So we're saying that it's everything except 0. Okay, now let's get to the behavior near the vertical asymptote. For us to answer that question, we have to approach that asymptote from both sides. Meaning, the vertical asymptote, remember, is, you said it here, it was the x equals 0 line. So we're going to have to, because it's a different answer depending on what side you're coming from. So we're going to have to answer this question two ways. As x approaches 0 minus, what does that mean? That means, go back to the graph, that here's my vertical asymptote right here. It's the y-axis. This means that as I get closer and closer to 0, coming from the left-hand side, what is the function doing? How is the function behaving? What is the function doing as I go closer and closer to 0? From the left, because it makes a difference which side I'm coming from. So does anybody have an answer for that? What is the function doing as I go towards 0? The vertical asymptote is at x equals 0. As my value of x gets closer and closer to 0 from the left, does anybody have an answer? You can put in the chat if you think you have an answer. What do you think is happening with the function as I approach it from the left? So from this side, coming closer and closer to 0. I'm not going to get actually to 0. It's not touching the origin. True. So give me what y value it seems to be going. Right? Where is the y seem to be heading? Because you're on the right track, Keontae. Right? What's happening to the y's as I get closer and closer to 0? From the left. From the left now. Okay, so to the left. Does anybody have an answer for that? All right, so I'll give you that answer. It's getting bigger. Thank you, Kayla. And if it's getting bigger, it's getting infinitely bigger. It means that y is approaching minus, you said bigger. I think you meant smaller because it's actually going down from the left. Would you agree with me on that, Kayla? It's actually going down. So it's approaching minus infinity. Okay, that's what's happening as I approach the 0 from the left. As I approach this same asymptote, because it's not the same answer, 0 plus, that's not, no, 0 is neither positive nor negative. So 0 minus and 0 plus doesn't mean a positive 0 and a negative 0. What we're talking about here is what side am I approaching the 0 from? So 0 positive means I'm approaching that 0 from the right. Let's go back and look at the graph again. Here's the graph. So now I'm looking at it and I'm thinking, as my x value is getting closer and closer to 0, what's happening to my y this time, right? Where's my y going? It's now going to infinity. Thank you very much, Harish. So y is now going to positive infinity. All right. Now, here's a question that's easier to answer than number 8. I'm going to tell you how to answer number 7, and I'm going to tell you how that's different from answering number 8, because they're not the same thing. And you need to wrap your head around both to be able to distinguish between both. Where is the function increasing? Let me put that to you a different way. Anywhere the function, which is a purple line in this case, is going up as you go from right to left, it's increasing. Right? So as you go from right to left, you want to make sure we understand this. As you can't go from left from what did I say? Right to left? That's wrong. Take that back. As you go from left to right, sorry. As you go from left to right, what is the function doing? Is it going up or is it going down? Because it's only increasing as you go from left to right if the function is going up. So, looking at the function you're looking at right now, the purple line, where is this function increasing? Where do you see the line going from left to the right, from left going to the right? Where do you see the function going up as you go from left to right? Anybody? Does anybody have an answer for that? Where is it going up? I need to answer the question of where the function is increasing. Anybody? The only time, only going down, I think Harish says. Okay. So Harish has one answer. Jeremiah, you want to offer something else? What do you think? Yeah, so yeah, that was the question we had for number 6. But what we're asking now is where's the function increasing as you go from left to right? And Harish, I think, has come up with the best answer. It's only going down. So the answer to this is never. It's never increasing, right? And what I mean is, yeah, when we're talking about as you approach 0 from the left, we're actually going from right to left, but we're only going from left to right to answer that question about where the function is increasing. So as I move this way, the function is going down. So anywhere from minus infinity up to 0 is going down. After you pass the 0 on the other side, it's still going down. So the answer to the question is what Harish just said, it's never going up. So the answer is never. It's never increasing. That's the answer. Okay? All right. Now, let's get to the other question. Where is the slope increasing? That's a different question. That's a very different question. An increasing slope means that as you go from left to right, if I put a line up against the edge of the function, think of IROC. When we did IROC a couple of weeks ago, a couple of days, whatever it was, we did IROC, we were putting a line up against the edge of the function and calling it a tangent line, if you remember that. And that tangent line represented the slope of the function at that point. Now, think of a tangent line that's maybe, in fact, let me put a tangent line on this function right now. Let me put a tangent line. Let's make it a different color. Let's make it red, right? There's a tangent line that I could put. It's a line, so let's use line. Oh, we're on line already, okay. Let's say the tangent line would be somewhere around here. That's a tangent line right there, okay? Now, think about that line for a minute. If I were to go further to the right with that line would start to rotate a bit. Would you agree with me on that? It would start to turn a little bit. It would start to get either steeper or less steep. And that's the answer to this question. Is it going to rotate in a clockwise direction or a counterclockwise direction? If I were to go with another line, in fact, I'll put another line on there, which is going to be a tangent here. All right, so that's another tangent line right there. How is that line turning? Right, because it is turning as I am moving along the edge of the function. Is it turning in a clockwise or a counterclockwise direction? Okay, so Elizabeth, Noah, Kayla, Keontae, everybody is saying it's going clockwise, and I completely agree with you. Here's the thing. When it's going in a clockwise direction, the slope is actually decreasing. Write that down somewhere. If I can put a little box on the side here and I can write that in for you. All right, so we're saying that a clockwise rotation of the tangent line is a decreasing slope. And I can explain to you why that is, right? Now, this slope here is a fairly flat slope, right? So this would have a value of, I don't know, let's just make up a number. Let's say that this slope here is fairly flat, would be about -1/2. It's a negative slope, by the way. But this other slope here is a much more steep slope, which would be maybe a -3. Now, which of those numbers is bigger? -0.5 or -3? Which one is a bigger number? Now, remember, they're both negative numbers. The -0.5 is a bigger number. So I'm going from a -0.5 to a -3. My slope is actually decreasing, right? Okay, no, thank you very much, Noah and Harish. So what I'm saying is that it doesn't appear as if the slope is increasing anywhere on this side of the function. It doesn't appear that way to me. Let's go on the other side of the function now, right? I'm going to get rid of these two asymptotes here. Let me delete that. And let me delete this one right here as well. Let's now put another asymptote in on the other side. And let's ask the question about how this slope is changing. I'll put that in as a red line this time. How is that slope changing on the other side? So let's say one asymptote is maybe about here. Okay, let's put another asymptote maybe about here. Now compare those two asymptotes. As I'm moving from one asymptote to the other, the line is rotating a little bit. What direction is it rotating as we move from left to right? What's the direction of that rotation? So the first asymptote I put on was this one right here, the one I'm pointing to right now. The second one I put on is this one right here. There's a bit of a rotation. So Emily is right and Keontae is right. This is now a counterclockwise rotation. And what that means is that now it's the opposite of what we said before. We said it was a clockwise rotation is a decreasing slope. A counterclockwise rotation, is actually an increasing slope. So where is the slope increasing? And I can demonstrate that to you in a minute as to why that is. Excuse me. It's similar to what we said on the other side. You have a very steep line first, and you have a less steep line. So it's like going from a -3 to a -0.5, a flatter negative. In this case, it's actually increasing. So where's the slope increasing? I'll put this answer in for you. Anywhere from 0 up to infinity. That's where the slope is increasing. Not at 0. We don't include 0, right? Because at 0, the function actually doesn't exist. But anywhere from 0 up to infinity, or put it another way, when x is greater than 0, the slope is increasing, right? So bear in mind what I said. Counterclockwise rotation means that the slope is increasing. A clockwise rotation means that it is decreasing. That's a different from what we said before. Where's the function increasing? Where's the function decreasing? Increasing and decreasing of the function just means is the function going up or down? That's it, down. That's it. As you go from left to right, is it going up or down? Is the slope increasing is different, and that has to do with how your hand is rotating. Put your hand up against the edge of the function or put a straight edge against the function and watch how your hand is rotating as you move it along the edge of the function, right? A counterclockwise means increasing, clockwise means decreasing. All right, enough said. I'm going to move on to my next graph. Does anybody have any questions about that? Let me just pause for a second and check in with the room on that. Everybody okay with that? All right, let's move on. I'm going to ask some of the same questions again about this graph. First question, where are the asymptotes? Before I even draw it, where are the asymptotes? Does anybody know where these asymptotes are, by the way? Let's start with the vertical asymptote. Does anybody think they know the equation of the vertical asymptote of this line? When we did this the first time, I'll take you back to the first one for a second. The vertical asymptote was x equals 0, and the horizontal asymptote was y equals 0. Does anybody think they know what the equation of the vertical asymptote is on this one? Anybody have any guesses on that? Anybody think they might know? Nobody? Let me make this graph a little bigger before I actually draw it. Once I draw it, I think you'll be able to see where the asymptote is, but does anybody know where it is? Nobody? So Shearbun thinks it's at a half. Well, first of all, it has to be an x equals or y equals thing when you're doing an asymptote, a vertical horizontal. But you're right. The vertical asymptote, and we'll talk about how we got that in a minute. The vertical asymptote is at x equals a half. Does anybody know where he got that from? Where did Shearbun get that from? How did he come up with that half? Anybody know? Apart from Shearbun, obviously Shearbun knows because he got it right. It's the divisor, it's the restriction. It's the same as restriction, he's right. In fact, the reason why x equals half is the asymptote is because it is the one value that x cannot be, because that is a restriction. Noah said it best, right? It is the restriction. So you look at the denominator and see what's going to make this denominator become 0. If I set this denominator equal to 0, if I took 2x minus 1 and set it equal to 0 and solved it, what value of x am I talking about? And the value of x is this value right here, x equals a half. So that is my vertical asymptote. If anybody now had to guess about the horizontal asymptote, what would you guess it is? I mean, I'll tell you eventually, but does anybody have a guess as to what the horizontal asymptote is? I'll tell you what the rule is, but I want to guess first. Right? I'm not going to draw it yet. I will draw it eventually, or the smart board will draw it. But can you guess where the horizontal, it does have a horizontal asymptote. Does anybody have a guess as to what it is? You think it's y equals 1? Jeremiah thinks. Anybody have another guess? Not saying Jeremiah is right or wrong. Just ask if anybody has another guess. Nobody wants to be, I forgot how to do it. Okay, that's all right. Does anybody want to hazard another guess as to what the horizontal asymptote? It does have one, just so you know. All right. So let me see if first of all, the smartboard is going to cooperate a little bit more now. Okay. Interesting. Can anybody tell me from the picture what they think that horizontal asymptote is on? Give me an equation of a line. Let's confirm that what we got as the vertical asymptote is in fact correct. In fact, I'm going to put that vertical asymptote in right now. Hopefully this thing doesn't freeze up again. Always put asymptotes in with dotted lines, by the way. You notice me doing that? I want to ask you to do the same thing when you're putting any asymptotes in for me, whether horizontal or vertical. So we're affirming that there does seem to be a vertical asymptote at the x equals half point. I need to shift that over just a little bit there. Just give me a second to see if I can move this slightly over. Yeah, there we go. Maybe a little bit more. Okay. All right. Sorry, this might be inconvenient, but at some point, could you please explain the behavior of the vertical asymptote? Okay. As we do the next one, I think you will probably get it the next time. Okay, Noah. So let's hold the thought for a bit and we'll come back to that. Okay. So now Jeremiah is changing his tune, and Keontae, you might be thinking maybe Jeremiah is right. It turns out we got the asymptote vertically, but horizontally it's the y equals 0 line again. And if I want to get a little rule about when it is, where's the horizontal, here's a little rule about it. If, I put it on the bottom here in a little box, if the degree, DG for degree, of the numerator is lower than the denominator, then, which is in this case, then the HA is the y equals 0 line. Is that the case here? Yes, it is. What's the degree of this numerator? Can anybody help me with that? What's the degree of this numerator? 1 over 2x minus 1. What's the degree of the numerator? No, it's not 1, Jeremiah. It's not 1. It's 0. Thank you, Harish. Right? It's 0. Thank you, Keontae. What's the degree of the numerator? Sorry, the denominator. The denominator. What's the degree of the denominator? Noah says 1. Absolutely. Absolutely. We talked about degrees before. So obviously 0 is less than 1, and that's why the horizontal asymptote is the x-axis or the y equals 0 line. That's always the case. So you want to make a little note of that somewhere. If the degree of the numerator is lower than the degree of the denominator, then the HA is the y equals 0 line. Not just for this one, but anytime. So if the top was a degree 3 and the bottom was a degree 4, it would still be the same situation where the horizontal asymptote is the y-axis, is the x-axis, the y equals 0 line. Okay. Let's talk about intercepts now. What about when it is not? Okay. Noah is jumping the gun. All right. So later on, we're going to find, thank you for the question, we're going to find that there is a different answer for when they're equal, which we're going to get to. So if they're the same degree, I'm going to tell you what happens then. I'm going to tell you today, but I'm going to tell you another time. And what happens if it's the other way around? That's a different situation. You're not going to have a horizontal asymptote at all. You're going to have a different kind of asymptote. So we're going to apply the rule, and we don't want to put too much into today's class, but we're going to apply the rule to the ones that we're doing today, which is a reciprocal of a linear function, so that every time we have a reciprocal of a linear function, it will be a case where the horizontal asymptote is the x-axis. There will be cases later on when, because the degrees are the same, something else will happen. And when the degree is the top is higher than the bottom, something else will happen again. But it's a very good question, Noah. Very, very good question. But we're going to answer that question in the future. Hold that thought for now. Intercepts. Let's get to intercepts. What is the x-intercept here? Let me start with that. X-intercept. Who wants to jump in on that? What is the x-intercept? What do you think the x-intercept is of this? Look at the graph and ask yourself. It's none again. Thank you. Wouldn't say 0 because 0, Harish, would suggest that it's crossing the x-axis at 0. So I wouldn't say 0. None is a better answer. I know why you said 0, but 0 would suggest that it's crossing at 0 because 0 is on the x-axis. So that's why it would be better to say none. But I know what you mean. You're thinking 0 means there are no x-intercepts. All right. How about the y-intercept? Is that none as well? Can't fool you guys at all. You're looking straight at the graph and you can tell that that's not the case. It does have a y-intercept. The y-intercept is in fact -1. Could we have figured that out from the equation though? Is there something in the equation that would have allowed us to figure that out? Right? If we didn't have the graph, which we do, I know we have the graph, but could we have calculated that with just the equation alone? Right? How would we have used the equation? And here's the equation up here, by the way. Right, I'll just click on it. 1 over 2x minus 1. How could we use the equation to figure out where that y-intercept is? Does anybody remember how to find y-intercepts generally from an equation? Anybody remember that? From an equation? Plug in 0 for x. Thank you, Noah. If I plug in 0 for x into this, I'm left with 1 over minus 1, which is what minus 1 is. We've sketched the function. Let's get to the thing that Noah has been asking about. Let's see if we can figure this out now. End behavior again refers to what's happening as the function, or was it because you're asking as it closes the opposite? Let me see what your question was, by the way. You're asking about behavior near the vertical asymptote. Okay, we'll get to that. We will, because that's going to be one of the questions we're going to ask in a minute. But let's start off with the end behavior and domain and range, and then behavior near the asymptote. So end behavior, as x moves to minus infinity, where is my y heading? Now that we've done this before, what do people think? As x moves to minus infinity, what's happening to my y's, right? So as I go further and further to the left, right, and you can see my mouse is moving this way. As I go this way, further and further out this way, y is approaching 0. Absolutely. As x moves to, and remember, end behavior can't just be on one side, it has to be on both sides. Thank you, Emily. Thank you, Arish. I have to approach it from the two sides. So as x approaches infinity, so I'm now going this way, what y value does it seem like I'm approaching if I go on the other side? Well, the answer to that is still 0. Still 0. Even before you answered, I thought I'd just put that in. Okay. Domain and range. Now, we answered the question for domain and range before, so hopefully this should help us out this time. What would be the domain and what would be the range of this function? So can anybody help me with the domain first of all? I can go back and show you what answer we got for domain and range before. In this case, we said the domain was all real numbers except 0. The range was all real numbers except 0. Okay? What do you say for domain and range this time? Okay, so let's see what Noah says. It's all real numbers with x can be equal to 1/2, and Kayla is agreeing and Karis is agreeing, and that's because they're all right. So it's all real numbers. Okay, that's very ugly. Let's fix that. It's all real numbers, but you can't have 1/2. How about the range? Good. Thank you very much, by the way. How about the range, folks? Right? What would you say is the range this time? Right? Remember, the range is all the y values. Let me take you back up to the graph. What would you say is the range of this function? Right? What are my possible y values? So it's that y cannot be equal to 0. There you go. So it's all real numbers, but just not 0. Okay. Now let's get to the stuff that Noah was asking about. And there may be other people. Noah was the one who was brave enough to step up and say, I'm not so sure about that. So let's answer the question for everybody else, not just Noah, right? And I applaud Noah for raising it. Behavior near the vertical asymptote. So behavior near the vertical asymptote is asking, as I approach that, remember, the vertical asymptote is at 1/2. So as I approach that 1/2, so as x moves towards 1/2, and I have to say from what direction, I'm going to start off by saying 1/2 minus, which means that I'm moving towards, and watch my mouse, I'm moving towards that 1/2 from the left-hand side. And as I get closer and closer to it, I'm trying to figure out what my y is doing. Where is my y? Where's the function? Where's the purple line heading as I get closer and closer from the left to that positive 1/2? Can anybody see what that is? Noah, can you kind of see what that might be now that I'm doing this again? What y value does it look like? Not just Noah, actually. There's what y value does it look like the function is moving towards? Where's the purple line heading as I get closer and closer to the half. What do you say, folks? Anybody? What y value am I approaching? Nobody seems to be sure what that is. Think about it. Let me show you again. Here's my half right here on the x-axis. It's a vertical line, x equals a half, this line right here. And I'm moving. And watch what happens to my y values. Are my y values moving towards something in particular, right? My y values are, this is my y-axis. I'm looking at where my y's are. Nobody thinks they can figure that out? It's moving towards infinity, Noah's thinking. What do other people think? Is Noah right? Is Noah correct? Should I put down that infinity? Nobody seems to be sure. The answer is actually minus infinity. Because the function is heading down, right? And it's going down, and it's going to be getting much bigger and bigger as I get closer and closer to that half from the left, right? Look at how the function is dropping as I move closer to it from the left. It's smaller, and I could show this to you on a Desmos graph. Maybe I should do that in a few minutes. Maybe you can see from a Desmos graph why I'm saying that the y value. No, so yes, no, it is in fact going towards minus infinity. Let me try another one and see if this is getting any clearer now. Let's try x approaching a half, but plus, meaning I'm approaching it now. Let me go back to the graph. I'm coming to the graph now from the right-hand side. So as I approach that half, but from the right, what would you say the y values are approaching as I come closer and closer and closer to that half? Along the x, where's the y's? What's happening to the y's? Anybody? It's going towards infinity. There you go. It is, in fact, going towards infinity. Thank you very much, Emily. Thank you very much, Noah. Thank you very much, Harish. Okay, next question. Where is the function increasing? Right? They're going up. Yes, yes. Yeah, as I go to it from, let me just go back and answer that question. As I move this way, the function is shooting upwards. Okay? All right, next question. Where's the function increasing? All right, what do you say to that? Let me show you the function again. Where is the function increasing? At what point along the function, from where to where would you say it is increasing? Never, just like the last time. Never, 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 never. Where is the slope increasing? Right? Now remember, we talked about this the last time, right? It has to be what's happening to the tangents. Put a tangent up against the line and watch how that tangent is rotating as you go from, it has to go from left to right. You must go from left to right, right? Where is the slope increasing? Can anybody come up with an answer for that, right? Where is my rotation counterclockwise? Because that's what an increasing slope means. From where to where is the slope counterclockwise? Anybody? Can anybody give an answer for that? All right. At what point does that start to happen? And where does it stop? From a half to infinity. Well done, Noah. Well done. So anywhere from a half up to infinity. Another way to say it is that when x is greater than, not equal to, a half, slope is increasing, and I use that up arrow to represent where it's increasing. Okay, from minus infinity to a half. No, not this time, Jeremiah. If you look at what Noah said, okay, let's do this. I'm going to stop sharing this screen, and I'm going to go to an application that I use sometimes for this called WinPlot. So I'm going to stop sharing this for a bit. because this is an important part of understanding how rational functions work, or all functions work. So I'm going to stop sharing this for a bit. Okay, now we're back on the smartboard. And remember, we agree that anywhere after a half, anywhere after this vertical asymptote is where the slope of the function is increasing, all right, because of that counterclockwise rotation. Let's move on. Let's move on. We'll try to squeeze in one more graph, this one right here, minus 2 over x plus 5. All right. Now we're experts at this now, hopefully. All right. Let's see if we can figure out a few things here. What would be my vertical asymptote? Let me write down VA and see if anybody can give me what the equation of the line is. Remember, it's an equation of a line. So VA. Does anybody know what the VA is? Noah says x equals minus 5. Emily is on that same, and Ava is saying the same thing. Absolutely. Okay, I'm not drawing anything yet. We'll draw this in a little while. How about the HA? Now, I've kind of given away what the HA is already. Harish says, and Joel, and Noah, and Jeremiah, and let's see, and Noah have all said the same thing. It's a y equals 0 line, because nothing has changed about the degree of the numerator and the denominator since we did the first one. The numerator is still lower than the denominator, so it's a y equals 0 line. So we know where the asymptotes are. In fact, let me go ahead and put the asymptotes in. Even before I draw the line, I'm going to put the asymptotes in. So one asymptote, I put it in as a red line, is that x equals minus 5. So somewhere around here. The other asymptote is the x-axis, somewhere around here. Okay, so there are my two asymptotes. All right. X and y intercepts, because if I have all of that, I should be able to draw this line. So let's start with the x-intercept. X-intercept. Okay, folks, where's my x-intercept on this function? Where do you think this x-intercept is? Anybody? Anybody? X-intercept. Don't think there is one. No, there is none. None. Still none. Because of the fact that the x-axis is an asymptote. Okay? How about the y-intercept? Where do you think the y-intercept is? At minus 2 over 5. Thank you very much. So that means that at minus 2 over 5, somewhere around maybe here, right, where that little dot is that I just put on, I should have my y-intercept. So what does this graph look like then? Well, here's what I would guess. We know it always splits apart, right? So maybe because of the fact that I have a y-intercept down here, it probably, and let me trace it out and show what I think it's going to look like. It's probably going to look something like this and like that on the other side. Instead of it being here and here, like the ones we've seen so far, it's probably going to be like here and here. Well, let's find out from the smartboard. Let's see what the smartboard says. Okay, let's try that again. Oh no. Oh no, don't do this. There you go. There you go. It's doing exactly what we thought it would do. It's following those asymptotes like we thought it would, and it's going through the point that we thought it would as well, right? So let's see if we can answer some questions. And that's a good way to sketch a graph, by the way. Put in your asymptotes, put in your intercepts, and then what you know about these rational functions makes it a little easier for you to draw the graph after that. Okay, end behavior. As x approaches minus infinity, y approaches what? Come on, we need to wrap this up. We're about 10 minutes before the end of the class here. Harish is saying 0, and because we want to move this along, I want to put that in. Jeremiah, go ahead, Jeremiah. You're going to say the same thing? You're going to agree. Okay, good. And as x, and remember, end behavior comes from both sides. As x approaches positive infinity, what's going on with my y's? It's still 0. Okay, so it seems like this Horizontal asymptote tends to tell you what's happening with end behavior. That's something you should write down somewhere, right? The horizontal asymptote does tend to dictate what's your end behavior. All right, let's keep going. Domain and range. Domain and range. We've done this enough times now so that we can sort of quickly get through this. What would be the domain of this function? The domain of this function. So x cannot be equal to -5. So it's all real numbers. So you need to say that, except that x is not equal to the -5, right? Remember that was your vertical asymptote. So that would be the thing that you're saying your x will be equal to. And the range would be what? We should be good at this by now. What's the range of the function now? Right? What is the range of this function? Right? Range is my y values. What y values? So it's everything except 0. Okay. Let's get to the behavior of the vertical asymptote now. The thing that sometimes we get a little bit messed up. As x approaches, where the vertical asymptote is at -5, right? As x approaches -5 minus. So remember, it makes a difference what side you're approaching from. We're going to do both. So -5 minus and -5 plus. Look at the graph. Look at the graph. As I approach that asymptote, let me put my mouse up against the thing here. As I approach the asymptote from the left, so from this side, asymptote is right here. As I approach it from the left, what's the function? Where's the function heading as I approach it from the left? Any answers for that? In the couple of minutes that we have left, we're trying to see if we can finish up this one here. It's going toward, is that positive or negative? Okay, Noah says infinity. It is increasing towards infinity, so infinity. As I approach this function from the left, sorry, I just did the left, sorry. As I approach this function from the right, so now I'm going at the function going this, thank you, Keontae, by the way, and Jeremiah and everybody else. But as I approach the asymptote from the left, I see some people have jumped in already and said negative infinity, and I absolutely agree with that. Negative infinity is correct. Okay. Now, the next question is, where's the function increasing? We've asked the same questions for every other graph that we've drawn. So it's the same questions, not always the same answers, but it's the same questions. So where is this function this time increasing? Answers for that. Everything except -5, Jeremiah says, sorry. What do other people think? Is he right? Is he right? Jeremiah seems to think it's everywhere except at -5. So is he right? Okay, there's a hesitation here. Some people are not sure. Minus infinity to -5. Okay, Harish agrees. And so you're thinking, no, it's only from minus infinity to -5 that it's increasing. Actually, Jeremiah is right on this one, right? Because you go from left to right, the function is going up. That's what increasing means. It's good. We're not talking about the slope yet. We'll get to the slope in a bit. But the function is going up. So that means it's increasing. On this side of the asymptote, it's going up. So it's increasing again. So where is the function increasing? Function is increasing at all real numbers, but not where x is -5. Right? Because the function doesn't exist at -5. So everywhere except -5, it's increasing. The function is increasing. That's one answer. Now, the more complicated answer that I know people have a little harder time wrapping their head around is, what is the slope of the function increasing? Let's go back and look at it again. And what I want you to do is put your hand up against the screen. It's your screen. Doesn't matter if you touch it. I mean, you're not going to get COVID through the computer, so you can touch your own screen. Put your hand up against the screen, right? And make a tangent out of the between your hand. You treat your hand like it's a line. Create a tangent against the function and move from left to right, always left to right, and see whether your hand is rotating in a clockwise or counterclockwise direction. Do it on both sides of the function. Do it before the asymptote, right? So on the left side, and do it after the asymptote, right? And let's see if you can figure out where the function is, sorry, where the slope of the function is. Let me go back up to the function again. Where is the slope increasing? From where to where? Anybody? Okay, Jeremiah. Oh, Jeremiah has an answer. He says from minus infinity to minus 5. Harish agrees. Keontae agrees. Was there any other answer, by the way? Did I miss an answer? No, I don't think I missed any answers. No. Okay. So everybody seems to agree with Jeremiah on this. Y'all think Jeremiah is right? All right. What about other people? What do you think, folks? Is Jeremiah right? Is it only from minus infinity? Is that it? Is it not increasing anywhere else? That's my question. I'm just trying to ask. I'm just my job. My job is to ask you questions for you to think it through. Is it anywhere else that it's increasing? Is it just from minus infinity to minus 5? Is that the only place it's increasing? What do you say? It's not because the other line is going clockwise. Ah, thank you. And clockwise means it's decreasing. So, thank you very much, Chianti. So, the slope is increasing from where Jeremiah said it was, from minus infinity to minus 5. That's where it's increasing. Okay? That is where it's increasing. No, we have about 2 minutes left, so we won't have time for any other functions. Here's the third one. I'll be asking the same kinds of questions again, but you have homework now. No, part of your homework is also to, yeah, I just said you were right. Okay, yes, absolutely, we did say you're right. All right. So let's give props to Jeremiah, by the way. Yes, absolutely right. I just want to remind you that on the homework for tonight, you will have to draw some sketches. And a sketch does not, let me just give you an idea of a sketch. A sketch does not have to be artwork. I don't need the Mona Lisa, right? I don't do anything as elaborate as that. All right. So, Jeremiah, yeah. I just need you to draw me an X and a Y line, put some asymptotes in wherever you think asymptotes need to be. I'm just making up some here. And then show me the general shape of the graph from there, right? Is it maybe that it looks like here and here? And just mark off where the intercepts are. If it has an intercept, just mark it off for me, please. Right? If there's an X and a Y intercept, you can just mark it off. If it just has an X-intercept, just mark it. If a Y-intercept, just mark that. So all I need is a pair of not coordinates, axes. What do you call them again? Those lines, okay? And I need you to put the asymptotes in. Any intersections, you put them in. Then just a rough idea of what the graph looks like. I do not need a Mona Lisa, okay? I don't need anything as intricate as that. Just a sketch will do. But it must be pretty clear that you understand what that sketch should look like. Okay, so I'm going to go off the clock. That's not on my watch, not on my phone, because for some reason that is not accurate. It looks to me as if we are out of time at 2:40. So I'm going to leave it there and ask you to make sure the homework gets done. And again, I'll see you tomorrow. Anybody needs to come and see me between 3 and 3:30, you know where to find me. Have a good evening. Bye.